Good news, everybody. The Patriots just scored a touchdown. They're playing the Buccaneers today, so go Pats, go. Even though they've got Tom Brady, we love Tom Brady. We really do. We really do love Tom Brady. But it's always good when your team wins. All right. So we've already talked about how to turn everything into a decimal. In case you forget, look back at these notes. Look back at those notes. We talked about how to turn everything into a decimal. Now, once everything's in a decimal, we can finally compare them. Let me say it one more time. To compare numbers, we turn them into decimals. Decimals. We need them all to be in the same form so that it's easier to compare them. It's hard to compare fractions because you have to get common denominators. You have to turn numbers into decimals anyway to compare them if they're in percent form. Just easier if you turn everything into a decimal. Very, very easy to compare them when they're in decimal form. Once we have everything in decimals, we like to line our decimals up and take a look, compare our place values. Compare our place values. So to the left of the decimal, we have ones, tens, hundreds, and then this is where in the American number system, we see a comma here between the hundreds, and then the thousands, 10,000s, 100,000s. Then we would see another comma. Then we'd see millions, 10 millions, 100 millions, comma, billions, trillions, and just keeps on going. And then once we get to those pieces of numbers, not the wholes, not counting, those pieces of numbers, that's where we see our decimals. Our tenths, our hundredths, our thousandths, 10,000s, 100,000s. We don't use commas on this side. But we do use these to help us see which numbers are bigger and smaller because they're going to get pretty close together. So, a few reasons why we compare and order numbers. If we're looking at statistics like we're going to be seeing in a project, you need to be able to compare, see which players are better, which products are better than others, which things give me the best value when we're comparing and ordering things. Sometimes we're going to be doing it because we see that we need to put things in ascending order. Ascending order means that we're putting numbers in order from smallest to biggest. Our numbers are going from low to high, from small to big. You might also hear least to greatest. And you might also hear the term increasing. All those mean we're going from small to big. Small to big. There we go. In Spanish, you might hear ascender. Same thing. Ascending, going from small to big. And then you might also hear descending order. Sounds like descender. We're going down from big to small, greatest to least. Or they're decreasing. Very important that we know, we see, we understand those words. Ascending, we're going up. Sorry, it's backwards. Descending, we're going down. Down. There we go. I'll get it one of these times. Descending, our numbers are going down. A quick reminder, any number to the power of 0, any number that has an exponent of 0 is 1. They're going to try to trick you. Don't let them. Any number to 0 power is 1. Let's go through and do some examples. There's a few different ways that you can see questions where they're asking you to compare or order numbers. And so these are 5 different ways that you might see them. This first one, we want to put these numbers in descending order. What does descending mean again? We're going from big to small, greatest to least. My numbers are decreasing. So we're going to go from biggest number down to our smallest number. So we see 4 different numbers, but remember, we want to put them all in what form? We're going to turn them all into decimals so that we can compare them easier. So our first number, 1.5%. What did we do to turn a percent into a decimal again? What does Beyonce say? Move it to the left, to the left. So this number becomes 0.15. Oh, girl, 0.15. I messed that up. Give me a second. Let's get some white out. 0.015. I'm using this line to help me line my decimals up so I can compare place value. So there's our first number. Now we have 1/5. What did we do to turn our fractions into decimals again? Divide. Top dog gets the house. 1's on the inside, 5's on the outside. Does 5 go into 1? No. Does 5 go into 10? How many times? 2 times. 2 times 5 is 10. Boom. So 1/5 is really equal to 0.2. This next one, 1.5, they did the work for us. So kind of them, already in decimal form. 1.5. And the last one, 1/15. What do we got to do again? We got to divide. 1 on the inside, 15 on the outside. Top dog gets the house. Does 5 go into 1? Nope. Zeros and some decimals. Does 5 go into 10? Nope. Another round of zeros. Does 15 go into 100? It sure does. I'm going to use some scratch paper to help me see how many, or I got space down here to see how many times. So if I count by 15s, I have 15, 30, 45, 60, 75, 90, 105. So there we've gone too far. So let's count and see how many times before we hit 100. 1, 2, 3, 4, 5, 6. 6 times 15 was 90. If we subtract, we get 10. So that means we got to bring in another 0. And we have this repeating pattern. I'm going to get to 6 again because it's 100 again. So 1/15 is going to be 0.066666 forever. Whew. Now we've turned them all into decimals. Now we can compare them to put them in order. A big thing here, put your answer in the given form. So when we're putting them in order, from greatest to least in descending order, I don't want to see these decimals. I want to see these numbers they gave us. So we're trying to find the biggest number descending. We're trying to go from the biggest to the smallest. So again, I need to look at my place value. So good thing we lined up our decimals. So looking at my ones place value, everything in front of my decimal, what's the greatest number here? What's the biggest number? This one's the biggest. 1.5 is my biggest number, so it's going to come first. 1.5. That one's been used. Now we look again. Now everything is zeros. So that means I have to slide over to the next place value. Now I'm comparing a 0, a 2, and a 0. What number is the next biggest? The 2. 0.2 is my next biggest, but that's not what I want to write for my answer. 0.2 was that fraction 1/5. So that's going to go next. So looking at our tenths again, now I just have 2 zeros. Those are the same, so I have to go out to the next place value, the hundredths. I have 0.1 and 0.6. What's bigger, 0.1 or 0.6? 0.6 is bigger. So that means that 1/15 is my next biggest number, which makes my smallest number my 1.5%. It's a lot of work. A lot of work. Keep in mind, we don't get calculators on this again. Like I said on the last notes, you don't get calculators on this. This needs to come from your brain. This needs to come from up there. Let's take a look at the next example. 2/3 is less than blank is less than 0.77. I need to find all numbers that are in between those two numbers. So first off, I need to convert everything to a decimal. Everything into a decimal. So first we have 2/3. Let's divide that and get that out of the way. Top dog gets the house. Does 3 go into 2? No. 3 go into 20? 6 times. That gives me 18. And I've got 20 again. 6 times. In case you forgot, 2/3 is 0.66666666 repeating. So I need to find a number that's between 0.666666 and 0.7. Between 0.66666 and 7. So let's write these numbers down. Because again, we're going to want to line up our decimals to help us compare place value. And I'm going to have 0.77. Is there anything after that 7? Just some zeros. If you want to write those zeros in, if that helps you see things, awesome. But if it doesn't help you, that's okay too. If it doesn't help you, that's okay too. All right, let's go through these 6 different numbers and see what works in my space. 77.5%. How do we turn that into a decimal? To the left, to the left. So it's really 0.775. Let's plug that in here and see if it works. I'm going to use my pencil so that I can erase it and just keep using the same thing again. 0.775. So just looking here, I need this number to be bigger than 0.6 repeating and smaller than 0.77. So is my number bigger than that 0.6 repeating? Yeah, it is. Is it smaller than my second number? No, it's bigger than my second number. So this one does not fit in that inequality. It's too big. Our next one, 0.32, they were nice for us. It's already in a decimal. 0.32. Is 0.3 between 6 and 7? That one doesn't work. Our next one again. In decimal form, they're so kind. So kind. 0.681. Is 0.681 bigger than 0.6 repeating? It's bigger than that. Is it also less than 0.77? Yeah. Yeah, so this one works. This one's good. This one works. This is good. Let's circle it. 3/5. Uh-oh. Back to decimals we have to convert. Division box. Top dog gets the house. So 3 goes inside, 5 goes on the outside. Five doesn't go into 3, but it goes into 36 times. So 3/5 is really 0.6. Let's compare it. Is 0.6 less than 0.6 repeating? Is 0.6 greater than that? 3/5 does not work for us. 62%. How do I turn that into a decimal? I move it to the left, So I go to the left, So it's really 0.62. Is 0.62 going to fit in here? Oops. No, 0.62 is too small. And our last one, 3/4. 3/4. What is 3/4 as a decimal? Think about quarters. A quarter is a fourth of a dollar. If I have 3/4, how much money do I have? 75 cents, 0.75. That's another one of those benchmark fractions. If you need to divide it, that's okay, but I'm not going to divide it. I know it. Memorizing these benchmark fractions will help you. 0.75. Is it greater than 2/3? Is it greater than 0.6 repeating? Is it also less than 0.77? Yeah, it's smaller. So that means that 0.75 works too. 3/4 is also okay. Also okay. If you need to pause that video to go back, catch up, write anything down that you didn't get, please do that now. Please do that now. Otherwise, if you're ready, I want you to try this one on your own. Select all rational numbers less than 3. I'm trying to find any number that is less than 3. Can it equal 3 if it's less than? Can't equal it. It's got to be smaller than 3. Less than 3. Go ahead, pause the video, try this one out all on your own. And then when you're ready, play it to check to see how you did. All right, hopefully you turned all these numbers into decimals first. 375% is 3.75. 9/3, remember that division bar that fraction bar means to divide. 9/3 is equal to 3. The square root of 25 is 5, because 5 times 5 is 25. Remember that from our first unit. 9 to the 0 power, any number to the 0 power, the exponent of 0 is equal to 1. And 33.33% is 0.3333. We need to select, we need to circle, identify every number that is less than 3. This one, too big. This one, it equals 3. It is not less than 3. That one was tricky. 5. 5 is bigger than 3. 9 to the 0 power, 1 is less than 3. 33.33%, 0.333 is less than 3. Okay. Let us know if you have any questions on those. Otherwise, we're going to move on. We've got two more examples. This first one is very similar to what was on our last test with our powers of 10 in scientific notation. First off, we want to put this in ascending order. What does ascending mean? It means we're going up. I was going to go right. I can't second guess myself. Ascending means we're going from small to big. When we talked about this when we were reviewing for our test, we said first look at what before you actually turn the number into a decimal or look at the number out front. We talked about looking at those exponents because the exponent tells us if it's a big number or a small number. So here, my exponents are -2, 3, and -4. So if I want to put these numbers in ascending order, I just have to look at those exponents to help me out here because they're all the same. So ascending order, what number is the smallest here? What number is the smallest here? I know a lot of us are probably going to say -2. Remember with the negatives, they get flipped around and they're in the backwards order. -4 is actually smaller than -2, so this one should come first if we're going from smallest to biggest. So first we would see 4.32 times 10 to the -4th. Then we would see -2. 4.32 times 10 to the -2, making our biggest number here 1.20 times 10 to the 3rd. We didn't even need to turn these numbers into decimals here. We could just look at the exponents to help us. If you have two numbers where the exponents are the same, then you can just compare the numbers out front. Those numbers in the decimal between 1 and 10. All right, one more problem I want you to try on your own. I have an orange, yellow, and blue eraser. Please put them in descending order. What does descending mean again? Descending means those numbers should be going down. Pause the video, try it on your own. At first look, it might look like the blue's the biggest one. Or at least that the orange and blue are close in size, but they're really not. Scientific notation times 10 to the 1st. I need to move my decimal point one time to the right. So the orange is actually the biggest. It's 32.4 centimeters. Then blue, 3.42 centimeters. And then yellow is the smallest. The square root of 9 is 3. If you have any questions on this, please let us know. Please let us know. Otherwise, we're going to give you guys some practice on quizzes. Good luck to you guys. Feel free to rewatch this, pause it, use this to help you while you're taking your quizzes. Good luck.